This next exercise is quite simple really. We're just looking at 4 different types of relations. Now we know that a relation is any relationship between x and y values that we can plot on a Cartesian plane. But for something to be considered a function, we say that functions are a special type of relation and they have to pass that vertical line test, which means that a vertical line that can go through them anywhere twice makes them fail it, whereas if the vertical line only can cut them once, no matter where you draw it, then it is a function. So passing that vertical line test effectively means that there's only one y value for each x value. Now, we usually use the graphs of functions to find some y value for a given x. After all, we said in the beginning, in our definition of a function, that x was the independent variable and that y depended on it. So it makes sense that we normally want to find out what y is when x is this or that. But it's sometimes helpful to read a graph of a function backwards, as we say. And what we're doing there is we're actually looking for some x values that produce a given y value that might be the thing that we're interested in. So a simple example here, perhaps we have the days in May graphed along the bottom, and we're looking at temperature, and we've measured the temperature every hour, say, for a month or whatever. Now, it might be that people say, hey, what was the temperature when you measured it on the 15th of May? And you might look along and go, 15th, oh, here it is, it was this temperature by reading off the graph. When you're doing that, you're finding the x value, looking up, and reading across to see the y value. But reading the graph backwards would be to say, all right, tell me how many days the temperature was over 23 degrees, say. And so you might find where 23 degrees is, make a horizontal line that goes across, and you'll be able to say, oh, it was above that temperature for 3 days here. So what you're doing there is you're finding a y value that you're interested in, and then you're reading down to see which x values it lined up with. Now, what you'll notice here is that when we read the graph the normal way, if it's a function, each x value only has one y. But for a function, when we're actually making a horizontal line, it's quite possible that a horizontal line is going to cross a function more than once. And so if you're looking for given x values that correspond to a y, you might get more than one of them. And this leads us into the whole concept of our 4 types of relations. Now, the easiest way to categorize them is just to go ahead and put this table into your books, and we can have a look at what it means. Now, we have a vertical line test and a horizontal line test now. We've already seen that the vertical line test says that to pass it, the vertical line cuts the graph no more than once. So it holds to reason then that a horizontal line test is exactly the same, except in this case, a horizontal line cuts the graph no more than once. So then a graph that passes the vertical line test and the horizontal line test has a 1-to-1 mapping, we say. So it means that every x value only has one y value that corresponds to it. But also if you read the graph backwards, every y value only has one x value. So it won't look like that rainfall chart that we just looked at, or the temperature or whatever it was. It will actually look something more like this. So some examples would be any diagonal straight line. Obviously, we don't want the straight line to be horizontal because then it's going to fail a horizontal line test, and we don't want it to be vertical or it will fail the vertical line test. But as long as it's got some diagonalness to it, it's going to pass both. Our hyperbola will also pass because even though it looks like a horizontal or a vertical line might cut it twice, it actually won't. And those asymptotes tell us that. We also can include our exponential graphs as one of these. Every single x value maps to one y, and each y only maps to one x. Okay, so many to one is something that's going to pass the vertical line test but fail the horizontal line test. So something like that temperature graph that we just looked at is a good example. Now what that means is a horizontal line will be able to be drawn that cuts this graph more than once. So our basic parabolas all fall into this category. Our cubic curves, quartics, any of our polynomials that do those ups and downs multiple times. A graph that is 1-to-many fails the vertical line test, but it passes a horizontal line test. So it's virtually the opposite of this. And if you turn any of these graphs on their side, then they're going to fail or pass the opposite test, aren't they? So a parabola that's on its side, like x equals y squared, which we touched on briefly in this unit, is going to be one of these sorts of graphs. And then something that fails the horizontal and the vertical line test would be a circle, because a vertical line cuts it twice, horizontal line can cut it twice. So it falls into that category. Now, the only tricky thing, I think, is this terminology, remembering what it means and how to recall which of these we're talking about. Well, when we're talking about x's and y's, and really this is talking about how the x and the y axis respond to each other or relate to each other, don't we always use the x and then the y? X always comes first, right? So that's how I remember. This is one x for every one y. This is many x's to one y. So think about what that means. If you went to draw it, you'd say there are lots of x values, maybe even only two, but there could be multiple, that have the same y value. So thinking of a parabola, if we had this point here, which has a given y value, then that y value is related to this x, but it's also related to this x. It's like it's partnered up with two different x values. So that's many x's, because there's two x's here, that are both saying, hey, I've got the same y value as a partner on this curve. So many x to one y. One x to many y, think about what that means. If you don't have the graphs in front of you, if you've got one x value, pick an x value, say x equals 2, how would it look if it's mapped to many y's? Well, many in this case can just mean 2. So if it had a y value that it matched to up here, but it had another y value it mapped to down there, then it would make sense that it would be one of those sorts of graphs, because one x is going with two different y values, okay? And many to many, I think that's probably the easiest one to remember actually, which is that it's going to fail the tests in both directions. I think the only two that are kind of confusing are these, and remembering that it's the many x's to the one y, one x to many y's, I think helps. Now bear in mind that lots of graphs use categorical data. It doesn't always have to be numeric, but even if it is numeric, it's worth considering what a graph would look like when you make it, so that you can consider which of these horizontal and vertical line tests it might pass. Let's look at this example. If we were graphing the number of pets owned by Bowral residents, would our graph represent a function? Classify the type of relation that it is. All right, well, let's picture what we would look at here. We're looking at all the residents of Bowral, and we're wondering how many pets they own. So as we survey different people, the different people would have notches along here. Now, perhaps I'm only going to survey 10 people. Maybe it's just the people in this class. I'm going to ask them how many pets they've got. What are some likely answers? 0, that's possible. 1, 2. Perhaps some people have a lot of pets, but we're probably going to have most people owning somewhere between 0 and 4 pets. Now, if we survey the first person and they say, oh, I've got 2 pets, we'll put a dot. Survey the next person, they have 1. Is it likely that we're going to have more than one person that has the same number of pets as someone else? Well, yeah, it is. So this graph, if we were to look at a pattern here, is going to fail a horizontal line test, because it's likely that there will be some number of pets that is owned by at least 2 people. Okay, it's very unlikely it wouldn't be. So we would say that it fails that horizontal line test. Now, is it a function? Well, can we let it pass a vertical line test? Yes, it would. Okay, so working out which one it is, have a think. There are many x values that would have the same y. So that's many x's to one y. So we'd call it a many to one relation.